Okay, one more quick thing about stem and leaf plots. If you've got a set of three-digit numbers, whether it's in with two-digit or whatever, if it's in with, well, I would say if it's in with two-digit numbers, you should probably do what I'm gonna show you with this. But you have a choice, all right? For three-digit numbers, you can choose to either make your stems be the first two digits, the hundreds and tens digits. So this goes from 150 something all the way to 228. I think that's the biggest number. So you could do 15, 16, 17, 18, 19, 20, blah, 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 all the way up. Or you could round them. And so in this case, the first one is 152. That's the smallest. So your key would be 15/2 equals 152 because you're using the hundreds and the tens digit as your stem and then the ones digit as your leaf. All right, or you can, if you need to be able to deal with your data in a better way, you can round the data. All right, so for 152, if you wanted to round it, I wouldn't round to tens, I would go by fives. So if you wanted to round it to 150, you could do 1 and a 5, and your key then would say 1 and a 5 equals 150. So it is possible that you could do that. There may be situations where you need to do that because it's just such a wide range of data. To make it manageable, you may want to round. Same with the dot plot. Sometimes with the dot plot, like I said, instead of plotting 67 and 68, you might want to round them just to 70 and plot them all at 70. That may give you a better picture of what the data is, especially if you have very few data points, but they're all, kind of clustered together, so to speak. And then one other thing with this one, you want to, even though I should have just written 21 and 22, there's only two more. You might look through this data and notice, oh, hey, there's no 190s. Could we just skip that? No. All right, that is important to show the gap there. So even though there aren't any 190s, you can't just skip to the 206s because there's a couple of 206s in here. So you can't just go from 180 to 20. You need to have that 19 in there to show the gap. All right, so be careful about that. Okay, so the last graph that we're going to talk about are box plots, and we're going to spend a little bit of time on this one because there's some formulas that go with this. Box plots, what they use to make them, so we're actually going to skip down here, is they use something called the 5-number summary. And you've seen these if you've taken standardized tests. 5-number summary. If you take a standardized test, I'm not sure if they show it with the SAT and the PSAT anymore, but like I know on my kids, when they get like the ITBS scores back or whatever, they have box plots on there. Because box plots are kind of showing you in a way where you are in regards to everybody else, but that's not exactly what they're showing. But anyway, the 5-number summary are the minimum value in the data set, the smallest value, the maximum value in the data set, the biggest value, the median, which we haven't talked about yet, that's actually further down on this page, but the median is the middle number. Your calculator can find it. We'll talk about how to find it by hand next time, but for now we're just going to go with a calculator just because we are. Quartile 1, which is the middle of the first half of the data set, so it's the ending point for the first quarter of the data. That's why it's called the quarter of the data. And then quartile 3, which is it's kind of the ending point for the third quarter of the data, so it's in between the third and fourth quarter. So it marks the beginning of the fourth quarter of data. Wow, I am having a hard time writing today. Okay, so it begins the fourth quarter of the data. All right, so hence why they're called quartiles. The median is actually also quartile 2. So the quartiles, quartile 1, 2, and 3, split your data into fourths. All right, so you've got this data set, a whole bunch of numbers. The median smack dab in the middle. Then this is quartile 1, quartile 3. And then you have each of these is 25% of the data. All right, so if you have, I don't know, 12 numbers, you're going to have 3 here, 3 here, 3 here, 3 here, divided by 4. All right, the other thing with this is we probably need to define outliers. So I'm going to go back up to all the definitions and we'll define what an outlier is. Outliers are data points that are outside the norm, kind of. They are that are far away, we could say, from the majority of the data. They're kind of the weirdo, basically, of the data set. So usually on a histogram, you'd see, if you had a histogram, your outlier might be over here or over here. You can have low or high outliers. For a stem and leaf plot, you might have a big gap and then a number down here, something like that. Like some of these, if you actually do the stem and leaf plot for this one, you'll see like there's a gap right here and then there's another one right here. So these 200s may be outliers. For a box plot, you actually can calculate whether something is an outlier. All right, to do that, you have to start by finding what's known as the interquartile range. Or we abbreviate that as IQR. And that is quartile 3 minus quartile 1. So you have to find that first. Then you have to find what we call fences. All right, these fences are your borders for what's an outlier and what's not. All right, if your data values are between these fences, then they are not outliers. If your data values are outside of the fences, they are outliers. And we'll do an example of this after we talk about the box plots a little bit. But that's what they are. They are basically the border of what's an outlier and what's not. So it's quantitatively saying, hey, this is an outlier, versus just kind of looking at a graph and being like, gee, that point looks weird. Okay, so our fences, how we find them is you do quartile 1 minus 1.5 times the IQR. And then quartile 3, you have two fences, one high and one low. Quartile 3 plus 1.5 times the IQR. Okay, and again, we'll do an example of this in the example there. Some advantages: the box plot split the data into fourths. Like you will see clearly when we draw the box plot where the quartiles are. So you'll be able to see that, and you easily see the middle half of the data. So you can kind of get a sense for what percent of the data is where, basically. And this is the easiest one. You know it's an outlier because you have to do the calculations to find them. So you see outliers easily. A disadvantage is that you can't, and we'll talk about this next time, but you can't see the shape of the data very easily. And we're going to talk about that when we talk about how to describe the data or how to describe the distribution. Okay, but that's something that at the moment you don't care about because you don't know how to describe the shape anyway. So in our data here, a report from the U.S. Department of Justice gave the following % increase in federal prison populations in 20 northeastern and midwestern states in 1999. And there's your data. Create a modified box plot. Don't worry about the word modified. Describe the distribution. And we're not going to describe the distribution now. We're going to describe it next time, next class. That's when we're going to do the description. So I'm going to bring up the calculator because we're going to do this in the calculator. You can actually draw the box plot in the calculator, but we're going to use the calculator to find the 5-number summary. Here's the calculator. I went ahead and went to Stat, Edit, and entered the data into List 1. There's two things that you could do. You could just do the box and whisker plot. I call it box and whisker plot, box plot on your calculator itself. But I want to show you how to get the 5-number summary because this also tells us some other things that we're going to use later on. So if you hit the Stat button, you want to arrow over to Calc, And you want to choose one variable stats. So you want number 1, and you just hit enter. You can, on the older calculators, you'll just hit enter again because they don't have this menu that comes up. But you want to, if you have the menu that comes up, make sure it's the right list, and then go down to calculate and press enter. It gives you a whole bunch of weird symbols. We'll talk about what those are. But down here starts your 5-number summary. So our min is 1.3, quartile 1 is 4.45, median 5.4, quartile 3 6.35, and max is 8. I'll show you how to do the plot on here. So we go to the stat plot. You want to choose the one with the dots. You want to choose the first one. That's what a box plot looks like. But it's the one with the dots. And then again, zoom number 9, and you can see this is what we should get when we graph it. All right, but we're going to do it by hand as well. Okay, so our min was 1.3, quartile 1 was 4.45, our median was 5.4, quartile 3 was 6.35, and our max was 8. All right, so that's what we had. When we graph it, if we have no outliers, each of these 5 numbers becomes lines on our box plot. To graph a box plot, you do need to draw a number line. Oh my goodness, look at how straight that was. So I'm going to go ahead and draw a number line and go ahead and label the scale. 8 is the biggest. And I could at least go in and put in the lines for the quartiles, so 4.45, 5.4, and 6.35, and that becomes our box. All right, that's the middle 50% of data. There's 25% of our data is between those two in that box, but that's the middle 50%. Now we have little whiskers that go out. Usually they go to the min and the max, but if we have outliers, they go to the fences, or they go to the next highest data point. It depends on whether you have the data or not. All right, and this is percent increase in prison. We want to title it as well. So to figure out our outliers, first thing we need to do is find the IQR. So we do 6.35 minus 4.45, and that is 1.9. And then we do our fences. So we do quartile 1, which is 4.45, minus 1.5 times our IQR, and that is 1.6. And then we do our upper fence, which is quartile 3, 6.35, plus 1.5 times our IQR, and our upper fence is 9.2. So we take a look at our data, and definitely not an upper one. There's nothing above 9.2. So there's no outliers in the upper range. The lower one, though, is 1.6. And we do have an outlier right here. 1.3 is an outlier. So what we do in that case, so the upper, no problem. We can put a dot, you can put a line, it really doesn't matter. And you draw a whisker out to that max. So we're putting that dot at 8 because that's our max. On the low side, since there's an outlier, what we do is we put a dot for the outlier. And if there was more than one outlier, you do more than one dot. So you do a dot for each outlier unless they're the same value. Then for your whisker on the low end, if you don't have the data, if you don't know what the next highest or lowest, whichever, data point it is, then you do your whisker out to your fence. So we do it out to 1.6. Since we have the data, we look for the next biggest number, which is 3.2, and that's what we're going to make the whisker go out to. So this is going to go out to 3.2. I'm just going to put 3.2 in parentheses. You wouldn't normally do that, but just so you know where that's coming from. All right, but if we didn't know, if we did not have the data and we couldn't look that out, we'd go ahead and go all the way to 1.6 because that'd be our best guess of where that should go out to. So that's how we do a box plot.